Good day everyone, my name is Kristian Labayno from BS ECE 3A. Today I will present my performance task number 3 at my ECE 23 subject. Let's start. What is pulse width modulation? Pulse width modulation is a powerful technique for controlling analog circuits with the microcontroller's digital outputs. PWM is used in the many applications ranging from the communications to the power control of conversation. Second, the PWM is basically a digital unipolar square wave signal where the duration of the on time can be adjusted or modulated as desired. What is the principle of pulse width modulation? Pulse width modulation is a modulation technique that generates variable width pulses to represent the amplitude of the analog input signal. The output switching transistor is on more of the time of the high amplitude signal and the off mode of the time is the low amplitude signal. This is how it generates the low average voltage, the narrow pulse, the width pulse, and the high average voltage. Let's proceed. Fundamental pulse width modulation scheme. There are two types, single-sided and the double-sided. The sample method PWM is traditionally also differentiated by the edge modulation and by the class. The edge modulation edge doubles the information stored in the resulting pulses string. Although the pulses string frequency is the same, the class AD and the class BD are the aberration of differentiate between two-level and three-level switching. Although the approach of synthesizing three-level waveform here differs from the method, the designation of BD is kept during the fundamental analysis by the coherence of previous work, and the resulting four fundamental P and PWM scheme are summarized. This is how the table summarizes. There are two types of single-sided modulation. First is the NBDS, or natural sample BD signal-sided modulation, and the second is NADS, or unnatural sampled AD single-sided, but we will tackle only the NBDS as required. This is the sample waveform of the NBDS. This is how the formula of NBDS. SR carrier is equals to 2 frequency C and the SR reference is equals to 2 pi frequency. This leads to the following more strict limitation of the frequency ratio. SR is carrier greater than the SR reference, or F is less than FC pi over pi, or F R V max is equals to I pi 1 over pi. Natural sample BD single-sided modulation. A simple approach to devise the DF expression is NBDS is by simple superposition, since NBDS can be synthesized by the 180 degrees phase shift of the modulating signal to the opposing modulator. Thus, MBDS T can be written as frequency NBDS times T is equals to FNADS times T minus FANADS times pi times T over 2. Subsequently, what is needed in general expression of NADS by the phase shifted modulation signal? This is how it formulates. Let's proceed. The individual harmonic component are identified to be IM component mx positive negative ny, and the amplitude is 2jn times m pi m over m pi sine n pi over 2. By comparing NADS and MBDS Hess plot, several important differences are observed. The Hess surface show very pleasant spectral characteristics, and the lower output level and the high frequency component disappear to ideal. This is the very important advantages of NBDS. Whereas all harmonic of carrier will represent in NADS, especially the odd. Second, the maximal IM component amplitude are lower than the NADS as the consequence of the synthesis of three switching level. The individual harmonic components are identified to be harmonic of carrier MX and the MI component of MX positive negative NY. And this is how it formulates. The harmonic of carrier is 2 times 1 minus JO times M pi M cos M pi over M pi. NBTS is seen to have severe common mode component all around all harmonic of switching frequency. Thus, the common mode signal is not much unlike the NDS differential signal in the terms of spectral characteristics. Comparing the differential mode and common mode of NBDS. But remember, common mode and differential mode signal are associated with both op-amp and interference noise is circuits. Common mode voltage gain result for the same signal being given to the both of the inputs of the op-amp. If both signals flow in the same direction, it creates common mode interference and noise. Differential mode is the opposite of common mode, and the direction of the signals are different. What is differential mode? This signal corresponds to differential mode signal. Differential mode noise and interference in electrical equipment is measured between the line-to-line voltage and high currents. This noise is transmitted through the inputs line of utility system, destroy capacitance between the circuit components and the magnetic coupling between the circuits can generate a differential mode noise. What is common mode? The signal flow through the two lines in the same direction in phase. When applying the right-hand thumb rule, the magnetic field associated with common mode signal might be opposite to each other. Common mode signals find the return path through the common ground. Parasitic capacitance between circuit's component and between the component of the ground are the leading cause of common mode noise in circuit. Parasitic inductance exacerbate the generation of common mode and interference in the circuits. This is how the waveform. Common mode characteristic of MBDS. It is the clear of the time domain waveform. NBDS generate a severe common mode outputs, whereas NADS does not generate any common mode components. A DFS expression can be derived from the output common mode signal as F of NBDS times C times T is equals to M frequency MADS times T plus MADS pi times T over 2. And how we get it. Then double the sum of the combined by using the trigonometric in, we get the following DFS of the NBDS common mode signal. This is how it formulates. You can pause this. This is the waveform of NBDS. The peak part is the carrier waveform. The dot line is the control voltage. And the waveform is the reference. This is the frequency domain characteristic of NBDS example. This graph. Summarize. Pulse width modulation is a powerful technique that controls analog signal with controller's digital output. PWM is used in many applications ranging from communications to power control and conversation. Second, pulse width modulation is a modulation technique that generates variable width pulses to represent the amplitude of an analog input signal. Third, natural sampled pulse width modulation is the most favorable form of modulation because natural sampling does not introduce distortion or delay of response. There are two types of single-sided modulation, NBDS or natural sampled BD single-sided modulation and NADS or natural sampling AD single-sided. Thank you. I hope you learn from me